What's up, YouTube? In today's video, we are going to be continuing on with our logging images, and we're going to be talking about custom loggers and friends. There are a bunch of classes there. But before that, I would like to also address certain questions or comments/questions that have come up either in the community and amongst my subscribers, but as well as on my team. So I thought it was important to discuss that. And I think there is an underpinning conceptual understanding or lack of understanding of certain things. So let me tell you what it is, and then I'll discuss that as well. And there's an announcement as well that I'd like to make before we start. So chapter markers should guide you if you want to skip things over. I suggest you don't, but you're free to do that. And the source code will be available on my GitHub. The source code link is the same as the link from last week, but the source code has been updated. So if you have downloaded the source code from last week, please be sure to update or get the latest version from my GitHub. Same link. I'll provide the link in the description below, but make sure you do that. Okay. The overarching question or misunderstanding revolves around dispose. So I think, and this is not like I'm just reminded of these problems or these questions that I answer repeatedly about dispose or IDisposable, when to dispose, when to know to dispose, why to dispose, why are we disposing, stuff like that. Things around dispose. So if you would like me to make a video on the IDisposable and why we need to dispose things on .NET, or when you know or can recognize when to do certain things, and if you build your own classes, what you need to do, let me know in the comments below, and I will be sure to make a video that just talks about that, probably under, so you think you know C#, IDisposables. Don't know yet, but let me know if you're interested. If that's a vague area for you, if there's enough of you that let me know that, then I shall definitely make a video on that. Okay. The logger provider in the source code that I've given you over the last 2 videos is an IDisposable, and it's an IDisposable for a reason. But it seems that even folks amongst my teams, people who worked with me for a few years, thought IDisposable was, well, it's IDisposable, it's okay, we don't really do much about it. And that causes a problem. So that's why I want to talk about that here. But there was an underarching question also to do with what is the value, if you will, of just logging and App Insights or Splunk for that matter. So I want to address that in this first part of this video. So when you log, you got log statements in your code, and generally most people have a lot of log statements in their code. No matter what it is, you want the logging to happen as soon as possible, as fast as possible. And so you're generally 90% and 99% of the time logging on a local hard drive. Now, the problem with that is not that this performance is slow, that's the fastest you're going to get is logging to your local hard drive. The problem is that hardware fails. Whether you're on premises or you're in the cloud, hardware fails. And so we generally, and I can only speak from my own experiences here, but I'm guessing everyone does the same thing. We generally have a mechanism to get those log files physically from that machine off onto a centralized server that has far more redundancy than your machines that you have running your applications on. So now towards that end, what if you did this without App Insights? So I'll give you an example of what I've done in the past as well. You're on premises, you're logging on the local machine, you got a load balancer in front of your application. So the load balancer will make sure your application's uptime is much more higher than a single machine, all right? Generally 99.99% if you have 3 instances behind a load balancer. And in Azure, that's sort of the minimum recommended to get that basic uptime. But individual machines or the hardware on those machines can fail, and they fail fairly frequently. I mean, you probably wouldn't believe that, but And I didn't either before the cloud as well. In fact, I remember on premises working in another company, and man, our hard drives failed way more often than we could ever imagine. So the problem with that failure on a single machine, hard drive failure or some hardware failure, is that these logs are sitting on this machine. And if you think you can get to those logs at some point in the future, you're mistaken, because that's not going to happen or may not happen. So as a result, what we would do, or what I've done personally, is the logger would log to the local file system. And the logger would in turn also publish a message to MSMQ on the local machine. Now, MSMQ is super, super fast. I'm always shocked when I work with MSMQ. It is just mind-blowingly fast. And of course, on the local machine. It doesn't use TCP/IP. It's using named pipes, which is another form of IPC. And what is that? IPC. Inter-process communication. There are 3 ways of IPC have been in Windows for many, many years, at least that I know of. TCP/IP, which can be inter-process within the machine, but can also go across machine boundaries. While named pipes and memory mapped files to other forms of IPC only work on the local machine. Named pipes, even SQL Server or LocalDB, actually SQL Server, if you install on your local machine, you have the option to use named pipes as a form of communication with your local SQL Server. So it's a fairly common protocol or practice and super fast. So the basic idea is that your application is logging to a physical file system, and simultaneously, or right after that, it publishes a message to MSMQ saying my file's there in certain folder, certain file name, or a message has been posted. However you want to do it, we should have a message per file. Another process, then on the same machine, it's a subscriber to MSMQ, and it gets the message instantly, almost. Goes and gets the file from wherever you said in the message where it was, and picks up the file, and it publishes it to the centralized server, your logging server, if you will, Splunk or AppInsights, let's say. So, cancel AppInsights, I don't want to confuse anything. Before AppInsights, we had Splunk, and before Splunk, there was no Splunk, and so we do this sort of thing. The idea is that the actual removal of that file from your local machine onto some centralized location was happening out of band async. And out of band async is my term. I don't know if other people use it. So it's happening asynchronously. As far as the application is concerned, the application did its work and continued on. It didn't have to wait for the whole transaction, if you will, to finish. And at some point later, some other process or another thread will take up that work and get the job done. The main thread is not waiting around for this work to be done. So I call it out of band because it's typically in a different process or a different thread. Not to confuse it with async IO. All right. In AppInsights, they use a concept similar to this, not MSMQ, but the idea is that because AppInsights is definitely going to be a remote call, a TCP/IP call to Azure, whether you're in Azure or on premises, it makes no difference. It's the TCP/IP call. So it's leaving your machine's boundary, going to another machine. So what they do at the AppInsights logger, it's all built into the logger. When you ask it to log something, it just logs it to memory. So it's basically in your own application's memory. And your application continues on, and so it's not held up trying to make that request to AppInsights and Azure, and what if it's not available, and how many times to retry, and all that stuff. So your application is not really slowing down or impacted by that process. Then on a different thread, the AppInsights logger, and these are in memory in your own application, so it's like a buffer. And on a different thread, that thread could either publish all messages in your buffer, in memory buffer, on a regular interval of sorts, or when the buffer is full. Either ways. I'm not sure of the exact settings that they might have for that, but definitely it's happening when the buffer is full, and also on regular intervals. It's going to push these messages off to AppInsights. And the same would happen for Splunk, for those of you using Splunk. In Splunk, what we do is we log to the local machine, and there's another process that picks up the files. And every 5-10 minutes, will push your logs to Splunk. So yes, you lose 10 minutes worth of logs if you were to lose your hard drive, but they're not sitting on your machine forever. So if you're logging and you don't think you need AppInsights or Splunk or something of that sort, think again. Even if you're hosting your own applications, well, if you're logging, I'm hoping you're logging with an intent. You're not just logging for the sake of logging. And if you're logging for a reason, then you would need to see those logs. In other words, it would matter to you or should matter to you that the logs could potentially disappear. So in that case, I suggest that you employ one of these mechanisms. Either use AppInsights with the AppInsights logger that's available to us in .NET, or you build this mechanism I talked about like MSMQ and do it that way to a centralized server that's got a much higher redundancy than your main application itself. All right, now towards that end, if you look at the source code here, this is the main program. Nothing has really changed here since last week. I create this logger provider, right? This logger provider is an iDisposable. Now, for some reason, even folks on my team thought, well, it's an iDisposable, so I'm sure Shiv's taken care of it or something of that sort. Anyway, whatever the reasoning was, from some of their responses and questions, I figured that, of course, that's a bit of a confusion there. Working with iDisposables, you need to understand, not that they have to be disposed, but there are complexities within your application, the way you set things up, the classes, and who's going to dispose what. That becomes fairly complicated. So some people think, oh, well, this class that created the iDisposable is responsible for freeing it, but then, and I'll explain that over here. So, sorry. So if I look at a LoggerProvider, why the heck is it disposable? The LoggerProvider is implementing iDisposable because it's working with a telemetry channel, which is part of your AppInsights thing, and the Logger Factory. Both are disposables. And because it is creating instances of these two disposables, it is its responsibility to dispose of them. And I think people are cool with this, with that sort of the first level, if you will. But who's using the LoggerProvider? And who's going to dispose that? And so on and so on. So it kind of goes up the chain. It's kind of like a virus. Anyway, without going too much detail into iDisposable, again, if you'd like me to make a video on a better explanation with some examples, let me know and I'll make a separate video on iDisposables. Nonetheless, what I wanted to get across here is because the LoggerProvider is a disposable, in the dispose method, the telemetry channel is being flushed before getting disposed. And that's the key. What was happening was some of our applications randomly would miss a few logs, and we were wondering, like, what the heck is going on? Why are some logs coming through and some logs not coming through, and on and on? Well, we weren't disposing the LoggerProvider, which is going to be flushing whatever was in memory in the application before the application shut down. Some of these applications that you shut down, they do their thing and they shut down. It's like not a function app, but very similar. So worker service. So those applications were showing this kind of a behavior because they come up, run, do the thing, and shut down. And before the AppInsights logger had a chance to do anything about sending the in-memory data to AppInsights, because probably the buffer was not full, nothing happened and we just wouldn't see logs. And sometimes we would, and it was just confusing. So if you've been using the LoggerProvider, be sure to dispose of it. Generally, not after you finish logging, but at the time your application is shutting down. All right. The LoggerProvider is not intended to be created multiple times. The intention of this LoggerProvider, by design, and everything it's holding on to, the factory and the channel, etc., is that you have one instance of it in your application's lifetime. So when the application is shutting down, it should be disposed then, no matter how you plan to use it. All right. Okay, so that takes care of the part. On the second part now is my announcement. It's not a big deal, but I want to get your input. Over the years, and fairly recently as well, even during my training period when I was training for a couple of years in the last not for the last 2 years, but prior to that, I was doing some training in the same place, but for about a couple of years. And I would get statements like, Shiv, you should, these things you tell us, like, standing in the corridor or, come by my desk and you start talking about something that's related to something else. All those things are important. Why don't you just make videos about these little things? 10-minute videos. You don't have to make super involved videos about these topics. I'm sure people would enjoy it. So the question to you is, would these little tidbits of information, knowledge, would be interesting to you? They may not be fully involved videos. There's certainly the intent of this series. I'm going to start a series if that's what you guys want. I'm going to call it like Fireside Chat, sorry. Or maybe not Fireside, because that means in the summertime I'm going to have to sit by a fireside. Something, even if I do call it Fireside. The idea is I'll very unlikely be sitting here, my sort of the studio, lights on and audio and computer, screen recording, all of that. So maybe I could be somewhere else in the house. I could be outside taking a walk. I could be on my cycle, or my motorcycle, or hiking, and it's like a vlog, I guess. But I'm talking about certain things that come to mind, but they're quite informal, but 10 minutes at most. And then if there needs to be a follow-on, that might be a more involved video to go deeper. But these are sort of trying to be limited to 10 minutes and fairly informal. So if you're interested in that kind of video or that series, let me know in the comments below. And depending on your responses and IMs or whatever, I shall decide whether I should go down that route or not. All right. This housekeeping is done. Moving on to the main part of this video, which is custom loggers. It's fairly simple. There are some gotchas. I just want to explain some of that. And of course, as I said, the source code is available to you, so you can do what you want with it. The intention here in this video, we're going to be building an in-memory logger. And this in-memory logger intention is to be used during testing. Which reminds me of another sort of, not a pet peeve, but I always wonder, sometimes I catch myself wondering. Yeah, some people ask me to do that also, so I'll see if I can start my videos, with some sort of a statement like that. Unit testing. I do unit testing in a non-traditional manner. So in other words, I don't use mocking, I don't use dependency injection at all, but I do a lot of testing. And these are very, very intense tests, very complete. When my tests run and all my tests pass, I can happily go to production. Zero concern about anything and hardly any bugs. If there are bugs, mainly it's because the analyst gave us the wrong information or incomplete information. So, they probably didn't. There's businesses, where we're building applications, so we can only account for a certain feature set. As we go from sprint to sprint, we can't account for every piece of feature set. And if you don't get the complete requirements, then from a business point of view, the system's not working. From our point of view, we didn't know we had to do it because nobody told us. But nonetheless, and I never get asked by you all about making unit test videos. And the ones I do make, nobody seems to want to watch. And that's a concern because every day, I'm dealing with people on my team, new people who join my team. Everyone either doesn't understand testing or is struggling quite a bit. Now, testing is hard, so I'm not saying that that's strange or unreasonable to be struggling for it. I think that's lacking. Anyway, I don't want to make this about unit testing. I'm going to make another video on that very soon, maybe in the next couple of days or tomorrow, whatever. So watch out for that. It's coming. It's just my sort of concern / case for unit testing. And then if you're interested in that, then I'll know if you watch that video. Or let me know in the comments below here if that's something you would be interested in. Be sure, I don't use dependency injection and mocking. So if you need to learn that style of testing, You're not going to find it here. But if you know how to do testing without dependency and in dependency injection mocking, then you shall, of course, learn that here. I do have a playlist on unit testing. I'll put a link up here for that, so you can go watch that. That's almost like a prerequisite to the next video I make. Okay, sorry. Logger in memory. So here's my logger in memory. It implements the ILogger, so nothing spectacular there. The ILogger essentially has these methods. All the ones that have the I next to them come from the interface. So these are the implementation of this interface. Now this logger specifically is not production ready. It's purely for testing purposes. So I'll point out some areas that I've taken shortcuts. In case you are planning to implement your own logger for production purposes, you need to address those areas, all right? For my testing purposes, this is just fine. Okay. All right. So we'll get to this log entries in a bit. So that's my constructor. It gets a category name, and I just persist that in a private read-only. Remember, begin scope. I don't use scopes in logging. So that's, if you do implement or use begin scopes in your production code, then this method will be called, and then you need to have the proper implementation here for your testing purposes. But I'm not doing that here since I don't actually need it. The is enabled, I'm just interested in log levels from debug all the way up to below, up to but not including the none. If you remember from the previous videos, this is an enum where the debug has a value of, let me see, what's it got? 1, and the none has a value of 6. And so between 1 and 5, right? In the real world applications, you would need to get your config information here and compare the config settings and figure out if this log level that was given to you is within the range of the config settings. And if it is, you return true, if not, return false. But in my case, I don't really care to do that. So that's another area that you might want to implement correctly. All right. Now, this is the primary method of all the logging. No matter what log method you call, it eventually calls into this method. So all of the other methods like log information, log error, etc., they all eventually call into this method. So this is the method that does the main logging. And as you can see here, we also have the state coming in, this T state, an optional exception or nullable exception, and the func or delegate that allows us to format the string. So I'm going to run this application, and you kind of put a breakpoint here so you can see it stop. Now this logger has already been registered with the backbone, as in the bootstrapper. So for logging purposes, there's the LoggerBuilder, I think, LoggingBuilder. That's doing the bootstrapping for logging. So independent of the dependency injection, if you're on a console or non-ASP.NET application, that's how you would set up your logs. So the LoggerProvider, let me show you that. It creates the logger factory, and then this builder is a logging builder, as you can see from the, right? It's an ILoggerProvider. So that's your bootstrapper for that. And I've already registered the in-memory logger here, which is why we're going to see that breakpoint being hit. And then I'm going to explain to you how you do that. How do you register your custom loggers with the bootstrapping infrastructure here, which is the ILoggerBuilder. What is it? Logging builder, right? Okay. In my program, it's got 2 logs. One is the sort of the standard log, if you will, with discrete arguments that get converted to properties. And then if you remember from last time, we have the insert blog post where we are logging a blog post. Right? So rather than having separate arguments, we have decided we have our own some DTO that we would like to log. And then this log debug takes that blog post as it is, and it'll log that. So it'll be called twice because we've got both the lines here. Everything else is commented out. All right. I'm going to run this application. And so it's stopped here. So the first time, we should see that there's a log level of debug. Let me zoom in case you can't see that. Event ID is some app event. State, it says debug log from method main execute step blah blah blah. And if you look at the state, it has count of 6, which is nothing but the key value pairs, as you can see here. And the key value pairs in this case are the event ID, event name, and so on and so forth. Okay. And exception, of course, we don't have one. In this case, it's null. And we have a delegate for the formatter. So what's going to happen is, because if you remember from last time, I said all states, all the T states. Oops, I don't know what happened there. The T state is a descendant of read-only list of key value pair of string object. So no matter what that state is, I'm simply casting it to that. And so I have a key value pair, and then this key value pair has really got my key values. Okay. And to get the message to format it, we need to call the delegate, passing it the state and the exception, of course in this case it's null. But that's up to the implementation that we have to do the formatting. And when I call that, I get the formatted message, which has embedded, if you will, the variables. So let me just show you what I mean by that. Can you see that? I don't think I've zoomed it in. Okay, there you go. Yeah. So it's filled in the properties in the string. So it's sort of a formatted string. Okay. And then what I do is I have another DTO here that I've defined called log entry. And let me show you what that looks like. It's essentially just a record that has these properties / arguments in the constructor. So it's got the log level, the event ID, the key value pairs, the message, and a nullable exception. So essentially what I'm doing is I'm logging all of this log information that came here into this log entry, and then I maintain a list of log entries, right? So each time, so I'm going to continue running this. It's going to stop back here on this for the second time. Let's come back here again. This time, the state has additional information. So in this case, the count is 8. And if you look at the results, you'll see that it's the blog post or title, and so on and so forth. So it's all coming here in the key value pairs, and then the same thing happens. Get the key value pairs, the message is not formatted yet. Format the message, and now we get a full out message with all the placeholders filled in with the values, right? And then that also gets logged into the list of log entries. So by the end of this, imagine you're using this log in your test. So in your act, your system does what it's supposed to do, and you've sort of provided this logger, in-memory logger, to your system in whatever fashion you're using, whether it's dependency injection or otherwise. And so anytime you do a log, this in-memory logger is also going to get called, and it's going to maintain all the data per log, per call to log in this log entries. So in your assertion now, you would have that collection available to you, and you can assert to make sure that the logger was in fact called. Now, with some discussions with my team members, they were actually surprised that they had to assert on logs. And I said, of course you got to assert on logs, because what are you logging for? Now, do you not want to know if you're doing the right logging? Is it logging? In the case of exception, we generally log at exceptions. And there are a couple of informational messages, informational logs for systems that are in the process of being developed. So if you're logging, you should assert and ensure that your system is doing the right logging. I'm more interested in the data. Is the data there? Right? So are the properties and their values there? Is the message somewhat containing some of these key properties that we've decided are key properties? So I'm not interested in checking for the message verbatim, but more the substrings, the properties. Are these properties being mentioned in the message? You can rearrange the language, but those values should be mentioned in the message. And of course, all those properties that are there should be there. The other key thing to remember is the key value pairs and the message and the placeholders, if you will, in the message, the curlies, they're independent, meaning at least in the AppInsights logger, and I believe even Splunk, Serolog, and other loggers will log all of the key value pairs as some form of properties so that you can query those logs separately. So it's not like your message has to include all the properties you intend to capture in your logs. So you can have certain number of properties in your logs, so in the message itself. But if you got 15 name value pairs in your key value pairs collection, they'll all get logged at least in AppInsights and Splunk, etc. So you can use that for proper filtering and setting up alerts. The reason is, yeah, exactly, alerts. The reason is that when we log exceptions, we also set up alerts. Call me whenever such a thing happens. Well, if you don't log correctly, you're potentially either not getting called when you should be, or you are getting called too often. And so, just keeping that in mind, there are a lot of other things that happen from the logs, a lot of alerts, and people take action. And there are large organizations with large people, many people. So, large people, many people having to do stuff before they even call you on the call. So that's why it's important. So you must test. Anyway, so that's what this in-memory logger is doing. Now, in .NET Core and .NET 5.6, in order to register your logger, your custom loggers with the infrastructure, with the logging builder, the one that bootstraps the logging for your application, 2 more classes are required. 1 more at least, but generally speaking, 2 more. So the second class you have to implement, or second interface you have to implement, is the ILoggerProvider. So let me show you that. So I've got another class here. I call it LoggerProvider in memory, and it implements. By the way, with interfaces, you don't inherit interfaces. You implement interfaces. Stop saying inherit. There's no inheritance in that sense. Sure, you inherit interfaces into another interface, but when you work at a class level, you are implementing one or more interfaces, not inheriting it. Okay, so here's this ILoggerProvider that we have to implement. And it's got 2 methods, as you can see here with the eyes. I don't know if you can see the eye there. That's what it is. Is an eye. Create logger that gets a category name, and you have to return an ILogger. So this is where you create your logger, whatever the new logger custom logger that you've defined. And this provider then is the provider for your logger, right? Now, it so happens that the in-memory logger has got nothing to dispose, so I'm not implementing it here. If your logger requires something to be disposed, you need to do it here. This dispose will be called automatically by the infrastructure if your programming is correct, by the way. Even here, if you don't, well, not here. If you didn't dispose ILogger, no, in the logger provider, if I do not dispose the logging factory, this dispose won't get called. It's a whole chain. So you got to be very careful with, not careful, you have to understand how things work. So you can implement iDisposable correctly, and implement by, I don't mean the interface, but everything in your code. Anyway. Empty here. And this is the logger provider that your logging builder needs to know. So, but in the logging builder, which is part of my logger provider, this is the logging builder. Essentially, this is an extension method. So, and I'm not a big fan of extension methods, by the way. But because this is common practice, I do it. Because what's common and what people expect, I do conform to. I personally will not define extension methods of my own choosing within my applications. Never. Well, I won't say never. There are a few cases, but in fact, I'll leave it for another discussion. See, that's one of those 10-minute videos, right? Okay. So because it's a convention, you should know how to do it, because that's what people would expect. And it makes it easier for people to discover your logger and for you to discover your logger and implement it and use it in the bootstrapping. So this method is an extension method. And of course, it's extending the logger builder, right? And that is in a different class here called the LoggerInMemoryFactoryExtensions. And it's got this one method called add in-memory logger, which is, of course, expecting the first argument, one and only argument, to be the logging builder. And since it's an extension method, you got this here. And this is the way you add loggers to the bootstrapping. All right. Now the add enumerable is in the case of loggers, you can have multiple things that implement ILogger, like console log and debug log and app insights log and event log and so on and so forth. So if you're adding multiple, if the service, logging in this case, can have multiple implementations all valid, all registered at the same time, then it's a collection of those ILoggers, right? And the try add enumerable is going to try to add your thing to that collection. And essentially what it's doing is it's going to try and add it, meaning if it's already there, if the same type, the class, not the interface, of course, the interface is already there. If it's the same type, the class is already there, it's not going to do it. If it's not, it's going to add it. So it's just like a safe way to add your loggers to the bootstrapper. It's also the recommended way to do that. So here we have a source descriptor that says this is the logger provider, and we give it this logger provider, which is our provider in memory. And the provider is the one that effectively creates the in-memory logger itself, the ILogger. Right? So it's a lot of ceremony behind this. But that's what it is. I mean, I think once you understand how it all works, the ceremony becomes a small part of the whole issue. Usage-wise, it works like any other logger, like add console, add debug. You say add in memory, and it just works, right? Okay, I think I've covered everything I intended to cover in this video. I hope you've enjoyed yourselves. I hope you've learned a few things. If you have, please give me a thumbs up, and I shall see you next time.